Okay, in this video we're looking at section 8.5, which is solving radical equations. The only thing different here in this particular section is that up until this point we've been looking at expressions, and the only difference now is that we'll be looking at equations. And remember, equations involve an equal sign, and whatever we do to one side we have to do to the other, and we'll actually be solving it. It's going to be important in this particular section that you check your answer, because sometimes radical equations, when you start going through the solving process, you might end up creating answers that are not really true solutions to the problem. And also, got it here in red, you cannot take the even root of a negative value. So we also need to check and make sure that when we're taking our square roots and fourth roots and so on, that the what's underneath that radical, what's underneath that root, stays a positive number. Okay. All right. So I've got up here at the top just your 4 steps to solve a radical equation that just has one radical. We'll bump it up to 2 radicals as we move through the set of notes. But the first thing you want to do is isolate the radical one. Don't get caught up on the word radical there. Basically, you're isolating the square root or isolating the cube root or whatever the root may be. So isolate the square root there. Raise both sides to that power. So if it's the square root, you're going to square both sides. If it's the cube root, you'll cube both sides. If it's the fourth root, to the fourth power on both sides, and so on. You'll solve the equation, whether it be linear or quadratic. And then lastly, you're going to check your answer into the original equation. And like I mentioned before, you might have an extraneous solution. And so if you have any of those, you'll just nix it. Okay, cut it off. All right, so let's jump right in. We'll look here at the first example. So in this first example, it's like if I'm following my steps up here, I'll put them back up here. It says isolate the radical. So that means isolate the square root. So the first thing I want to do is get closer and closer to getting that square root all by itself. So in order to do that, I take my 3 to the other side. If you cross the equals mark, do the opposite. So I'd add 3 to both sides. Cancels out. So then I'm left with the square root of x equals 7. Now, square both sides. Square root of x squared, right? Remember, like we talked about before, anytime you take a square root and square it, you just get what's underneath. So x equals 7 squared gives us 49. And so then that would be your solution. We'll box it in here, but it's always a good habit to check yourself, and we will have to check ourselves moving forward, but I'll show it here. This one you can almost eyeball it, but you have the square root of x. I'll just rewrite my original problem here, equals 4. So in place of that x, I'll put in 49. Trying to see, really what you're trying to do is, does this equal 4? Well, sure enough, the square root of 49 is 7, and 7 minus 3 definitely equals 4. So that is x equals 49 is definitely our solution. All right. We'll step it up a notch in the next one. So you'll notice here in this next problem that the square root is already isolated. It's already by itself, so you're already ready to get rid of it. So you're going to, since the square root, we're going to square both sides. So whatever we do to one side, we're going to do to the other. So we'll square over here, square over here. Now remember over here on the left side where you say x minus 9 all squared, remember that doesn't mean that you just square the x and square the 9. That really means that you write x minus 9 times x minus 9. Whatever's in that parentheses gets written twice. I don't really have to worry about it over here on the right, because anytime you take a square root and you square it, you just get what's inside. So you just get x minus 3. Because essentially what you're saying is the square root of x minus 3 times the square root of x minus 3. And we talked about in a previous section that anytime you do that, you always get what's inside. Okay, so now over here on the left hand side, hopefully you agree, I just need a FOIL. So x times x squared. Outside, x times negative 9, so minus 9x. Inside, another minus 9x. Last, negative times negative gives me a positive 81, equals x minus 3. Let's combine like terms. My goal is to solve for x. So x squared minus 18x plus 81 equals x minus 3. Now from here, I want to get all of this equal to 0 so I can solve for this x. So I'm going to subtract x and add 3 to both sides. There we go. Subtract x and add 3. So that cancels out over here. I'm going to be equal to 0. So then I'm left with x squared minus 19x plus 84. All right, like we said, it's either going to be a linear or quadratic to solve from there. So we've got a quadratic here. This looks like something we should be able to FOIL. So I'm going to go x and x. A common way to multiply to give you 84 is 12 times 7. And 12 and 7 can definitely give me 19. Since I want a negative 19, I'd have to make them both negative. And then if I set both of these factors now equal to 0, x minus 12 equal to 0, and x minus 7 equal to 0, then over here I'd add 12, of course, and so I would get x equals positive 12. Over here I'd add 7, and I would get x equals positive 7. All right, so now if I go through and let me do my check, let's use a different color over here. So for the check, go back to your original problem. X minus 9 equals the square root of x minus 3. So if we plug in, we'll do the 12 first. So if I plug in 12, then I have 12 minus 9, trying to see does that equal the square root of 12 minus 3. So 12 minus 9, of course, is 3. 12 minus 3 is 9. So I have the square root of 9, and definitely the square root of 9 is 3. So 12 is definitely a solution. So I'll check that one off. All right, let's check the 7. Is 7 minus 9, 7 minus 9, jumping ahead of myself, is 7 minus 9 equal to the square root of 7 minus 3? So 7 minus 9 gives us negative 2. 7 minus 3 is the square root of 4. And the square root of 4 is positive 2. So positive 2 does not equal negative 2. So therefore, only positive 12 is our solution. Okay. All right, we flip it on over. Next page. You'll notice the only thing different here is that you've got a cube root. So as I mentioned before, to get rid of the cube root, we're just going to cube both sides. But before I can do that, I need to get that cube root all by itself. So I'm going to pull that 5 to the other side. So just subtract 5 from both sides. So I have the cube root of 2x plus 1 equals negative 5. Now, like I said, let's cube both sides. Cube, cube. Cube root of something cubed just gives me what's inside. So 2x plus 1 equals negative 5 cubed. Remember, that means negative 5 times negative 5 times negative 5. You should get negative 125. And now I'll just go through a couple of steps here. This is linear, so I just subtract 1. 2x equals a negative 126, and then divide by 2. So that we're just left with plain old x equals a negative 63. That's it. And then we can do the quick check over here for ourselves. For our check, we've got the cube root of 2 times negative 63 plus 1 plus 5, trying to see does that equal 0. So I've got the cube root of negative 126 plus 1 plus 5 out here. So the cube root of negative 125 plus 5. The cube root of negative 125 would be negative 5. And negative 5 plus 5, sure enough, is 0. So negative 63 is your final answer. Okay. What I would recommend you do is to pause the video right now and try the next example by yourself. I'm still going to work through it here and talk through it. And then I'm not going to worry about doing the last. Well, I guess I will. I guess I'll just go ahead and do this entire page here. But anyway, I think I'll, actually change that. Here's what I'm going to do. The next one is fully worked out online in the solution key, so I'm going to let you try that one. You just need to isolate that square root there and go from there, okay? So I'll look at the last one because it's a little different, even though it doesn't look like it's a hard problem, and it's really not, but it's different. So let's go ahead and do this last one. You're trying to solve for this q down here. So what I would recommend us do is let's just put a 1 underneath that 6 and let's cross multiply. So 6 times the square root of q is 6 square root of q equals 1 times 1 is 1. Now from here, just square both sides because your square root's already by itself, so just square both sides. So 6 squared 36. The square root of q squared is just q, and 1 squared is 1. And then last step, divide by 36. cancels out. So Q equals 1 over 36. If we do our check, you have over here, you're asking yourself, does 6 equal the square root of 1 divided by 1 over 36? Well, over here in this square root, you've got a fraction within a fraction. So the rule is that you copy, change, flip. So it would be 1 times the reciprocal, 36 over 1. Well, 1 times 36 is just 36. And sure enough, the square root of 36 is 6. So 1 over 36 is our final answer. All right, if we flip it over, I believe this is your application. Oh, nope, not quite. On this next page, we are looking at solving radicals that have solving equations, radical equations that have more than one radical. And so sometimes what that will entail is that we're going to have to use our idea of squaring or cubing multiple times, more than one time. So here in the first example, you've got 2 square roots, but the nice thing is you've got one on one side and one on the other. So I would just immediately go to, okay, let me square both sides. Square both sides. And so now the square root of x plus 1 squared is just going to give me x plus 1. Over here, that square root square is just going to give me what's inside, x plus 3. Our goal from here, solve for x. So it doesn't matter which x you take over. Look what happens. Cancels out on both sides, and you're left with 1 equals 3. Well, that is definitely not a true statement. 1 will never equal 3. So this is a case where you have no solution. Final answer there. All right, so let's scoot on down, step it up a notch, and looking at the next problem. So again, you've got 2 square roots. You always want to isolate one of them, okay? So it does not matter which square root I take over. I think I'll just take over the second one though. So I just subtract the square root of y from both sides, the square root of y. So that way it cancels out over here. I've got 1 square root all by itself. So y minus 7, square root of that, equals 7 minus the square root of y. Now from here, if I square both sides, square, on the left-hand side, you square that square root, you're just going to get y minus 7. On the right-hand side, remember, that means I'm going to need to write that twice, so I'm just going to do it like right here and FOIL it. So I have 49 minus 7 square root of y minus 7 square root of y plus y. And square root of y times square root of y is just y. I combine like terms, I have y minus 7 equals 49 minus 14 square root of y plus y. Now from here, my goal is still to solve for y, but you'll notice, I've got a regular y and I've got a square root of y. So in order to solve for y, I need this square root term here isolated all by itself so I can get rid of the square root. So in order to do that, I'm going to take the 49 and the y to the other side, put it underneath its like term, so subtract 49, subtract y. That way then those y's cancel out. I'm left with negative 56 equals negative 14 square root of y. Now technically from here we could square both sides, but I will show you this little technique. What you can do from here is divide both sides first by negative 14. Divide by negative 14. That way you cancel out. Negative 56 divided by negative 14 gives you a positive 4. Come up here. Positive 4 equals the square root of y. Now squaring is, and I know you got a calculator, but nevertheless, I'm not sitting here with one. So now if I square both sides, because I don't know what 56 squared off the top of my head is. So square both sides, I know that 4 squared is 16, and then the square root of y squared is just y. So after we squared both sides, now you have y equals 16. So that would be your solution to do your check. Do our check here. You have the square root now of 16 minus 7 plus the square root of 16, and we're trying to figure out, does that equal 7? I'm just going back up here to the original problem. Square root of 16, sorry, let's do this first. 16 minus 7, that's not legal. 16 minus 7, of course, is 9. And then I'll just burn an extra step here. Square root of 9 is 3. Square root of 16 is 4. Sure enough, that equals 7. All right, so now if we'll move on down to the next one. It's very similar to the last one, so if you want to try it, if you want to pause and try it solo first and then come back to the video, that's maybe a good idea. So now from here, if I'm looking at this next one, first thing I would do is get one of these square roots all by itself. So I'm going to just take this second one over here, the square root of x plus 5, and take it to the other side by doing the opposite, so subtract. Cancels out. Square root of x minus 3 equals 4 minus the square root of x plus 5. So now from here, square both sides. Take a square root and you square it, you just get what's inside. So x minus 3 equals, over here I will need to write that twice so I can FOIL it. So then I have 16 minus 4 square root x plus 5 minus 4 square root x plus 5. Just FOILing here. Square root times the square root just gives me what's inside. It's a negative times a negative, so it turns into a positive x plus 5. Over here on the right hand side, let me combine like terms. So that would be, I'm going to go ahead and combine my 16 and my 5. So the 16 and 5 here, that will give me 21. Negative 4 and negative 4 give me minus 8 square root x plus 5. And then I have plus x. All right, just like last time, I'm still trying to solve for x, but I've got a regular x and I've got a square root of x. So I've got to get this square root of x isolated before I can be able to fully solve for it. So I'm going to take the 21 and the x to the other side. So subtract 21, subtract x. Cancels out, cancels out. Even these x's over here cancel out. So I'm left with negative 24 equals negative 8 square root x plus 5. Then divide both sides by negative 8. And then I'm left with, I'll just go ahead and get it. Negative 24 divided by negative 8 gives me a positive 3 equals this square root of x plus 5. And now square both sides. Get rid of that square root. 9 equals x plus 5. Subtract 5 from both sides. And we're left with x equals 4. And then if we go back and check ourselves, different color. So doing the check, I'm looking at the square root of 4 minus 3 plus the square root of 4 plus 5. Trying to figure out, does that equal 4? Like I said, going back to this original problem here. Square root, let's see, 4 minus 3 gives me 1, so the square root of 1. 4 plus 5 gives me 9, so square root of 9. Square root of 1 is 1, square root of 9 is 3, and 3 plus 1 definitely equals 4. Final answer. So x equals 4 is indeed a solution. Okay. All right, if we flip it over to the next page, you just pick up a couple of applications. I'll do the top one with you. The bottom one is Pythagorean theorem. I think you be able to look, and I'm sure you've worked with Pythagorean theorem before, as well as by looking at that solution key, you should be good to go with that one. So here they tell us the time t in seconds for a pendulum of length L to make one swing is given by this equation. So t equals 2 pi on the square root. They want to know how long will it take a 3-foot long pendulum to make 5 swings. So remember that your L here stands for the length of the pendulum. So I would take, using my formula for part A, t equals 2 pi square root L divided by 42. So I know how long it is. It's 3 feet long. So t equals 2 pi square root of 3 divided by 42. And I would literally type this in my calculator exactly how you see it here. 2 times pi times square root 3 divided by 42. Hit enter. You get t equals about 1.68. Then that would just be, because remember your formula up here only gives you the time to make one swing, and we want to make 5 swings. So just simply take that and multiply it times 5. And so that would be 8.40 seconds. Final answer. For part B, it says, well, how long is a pendulum if it makes us one swing in 1.2 seconds. So this time they're giving us the time. So looking at our formula, t equals 2 pi square root L over 42. This time I know my time, so I'm plugging in for t of 1.2 equals 2 pi square root of L over 42. You just want to get closer and closer to solving for this L. So I'm going to divide by 2. I'm going to do this in a couple of steps here. Divide by 2. You get 0.6 equals pi on the square root of L divided by 42. Then I'm going to divide by pi. You should have a pi button in your calculator. It is usually a second feature. It's second and it's the key right above your division symbol, underneath clear and above your division symbol. So you hit the blue second key, and then it's really called the caret. And that caret symbol is between clear and the division symbol on the right-hand side. 0.6 divided by pi is approximately here 0.190985, just showing a little bit of work here. But technically at this point you could just keep it all in your calculator, L divided by 42. Now to get rid of that square root, it's isolated all by itself, so square both sides. So over here then that just leaves me with L over 42 equals, and if you square that, approximately you're getting 0.03648. I'm sure it keeps going. I'm just giving you a little bit of some numbers here so you can make sure you're tracking in your calculator. At this point I'm just showing work here, but as far as like if I were doing it, you know, if this were like a quick problem on a quiz or something, I would be kind of writing these steps like you see here, but my final answer would be that I'm not doing any rounding until the very end. So now this is L divided by 42, so I want to get, since it's division, I'm going to multiply both sides by 42, multiply by 42. So it cancels out, and so L equals, so then I'm taking that long number in my calculator, multiplying it now times 42, and then I'm going to round to the nearest hundredth. So rounded to the nearest hundredth, now I'm going to say 1.53, and the length was measured always in feet. Okay, and that's your final answer. All right, and if you flip it over to the last page, I've just uploaded online in Blackboard the solution key to this page. I know that on the full answer key it was actually not visible, so I've got that corrected for you now. I just want to do one problem on here because I don't think it really came up in the notes where we would have more than one. I think it only came up once. I just like to do one more here with you. You'll notice in the notes too that I'm going to ask you number 9 and number 11. You can skip those. We haven't talked about those, and technically you don't have. We need the next section for you to be able to fully solve number 9 and 11, so you can skip those. I just like to do number 5 with you, and then this next page this page here is a great practice for yourself. I highly encourage you to do it, and I have a fully worked out solution key for you on Blackboard to check yourself by. Okay, so here in number 5, you've got your square root already isolated, so I'm just ready to go ahead and square both sides. Over here on the left-hand side, x minus 7 squared, remember that just means write x minus 7 times x minus 7 and FOIL it, so you get x squared. Look here, outside minus 7x, inside another minus 7x, so hopefully you're tracking with me. I'm going to have minus 14x, negative 7 times negative 7, positive 49. Anytime you take a square root and you square it, you just get what's inside. Okay, so now from here I've gotten rid of my square roots, so I'm just ready to get these x's all together. So I'm going to subtract 4x and add 7. So that way we cancel out. We're now equal to 0, and we're going to have x squared minus 18x plus 56 equal to 0. Now we're ready to factor x and x. Multiply to give you 56. You know, usually you probably go straight away to the 8 times 7, but that doesn't work here to give us 18. But another way to get you 56 is 14 times 4. Since you want a negative 18 in the center, you need to make both of them negative. And then if you set both of those equal to 0, if I set this one x minus 14 equal to 0 and solve for x, I'm going to get x equals positive 14. If I set x minus 4 equal to 0 and solve for x, I'm going to get x equals positive 4. So now if I check myself, so if I plug in a positive 14, then I'm looking at 14 minus 7. Does that equal the square root of 4 times 14 minus 7. All of that's underneath the square root. So 14 minus 7, of course, is 7. 4 times 14 is 56. 56 minus 7 is 49. And sure enough, the square root of 49 is 7. So 14 is a solution. Try the 4 then. 4 minus 7 equaling the square root of 4 times 4 minus 7. 4 minus 7 gives me negative 3. You can almost stop here. When you take a square root, you're not going to get a negative value. But I'll go ahead and continue working. That's going to give me 16 minus 7. And then you get the square root of 9. Square root of 9 is a positive 3. And here we're getting a negative 3. So that's why here x equals 4. That's what we referred to before. It was an extraneous solution. So, all right, let me know if you need anything. Thanks a lot. Bye.